I will demonstrate laboratory exercise 2, and I will prove that a given grammar is ambiguous using the Backus-Naur form and parse trees for expression a+b+c. And this is my work. First, let me present the grammar we are analyzing. S arrow to A and A arrows to A plus A, or an identifier, and the identifier arrow to A or B or C. And this is our Backus-Naur form grammar. So the goal is to derive the expression A plus B plus C and to prove that this grammar is ambiguous by showing it can produce multiple parse trees for one same string. And let me show you how to construct the first parse tree using the leftmost derivation. So this is, and then in leftmost derivation, we always expand the leftmost non-terminal symbol first. So I have it here. Let's do the demonstration. First step is we start with S, and then S derives to A in our rule that S arrow A. And the next thing, step 3, our A derives to A plus A. Using the rule A arrow to A plus A. If you could see in our rules here, this one. Okay. So next, since this is leftmost, so we will expand the leftmost A. So since this is A, then it will produce A plus A. And then still, A becomes an identifier, and the identifier we have A. And in the next node, A becomes an identifier, and identifier becomes B. So we produce A plus B. This is A. And then we will move to the next node. We have an operation plus, and then we have A. A becomes an identifier, and it becomes C. So A plus B in our left child, and then plus C. So it becomes A plus B plus C for the leftmost. Now, in our second um, derivation is the rightmost derivation. So um, let me show you the second way to derive the same expression using the rightmost derivation. So in left, we start to the leftmost. Just same with the rightmost derivation. We always expand the rightmost non-terminal symbol first. So we have it here, our second picture. So we have it here. We also start with S, and S derives to A using the rule S arrow A. So step 3, A derives to A plus A. Using the rule A arrow A plus A. So now we have A plus A. And the next thing we do is we will expand the rightmost A. So A, since this is the rightmost, if you can still remember in the leftmost, we started to expand the left. But this is the other way around in the right. We expand the rightmost A, so A becomes A plus A. So now, on our next step, A becomes, I mean, ID. ID. So we have a ID. So we already expanded the rightmost A, and then we go back to the A, becomes ID, and ID becomes A. So we have A. So why is that A cannot be A plus B? Because these are all on the right side. So we will continue with the operator a plus, so A plus, and then the next thing is we will continue the right part. So A becomes ID and ID becomes B. So A plus B, then plus, and then A becomes ID and ID becomes the identifier becomes C. So it will becomes A plus then B plus C. So this derivation creates parse tree with the right interpretation. So meaning we group it as A plus then B plus C. The structure shows that we first add B and C, then add A to that result. So let's go back to our answer. So we have two derivation. Let's clear this one. We have A plus B, then plus C, and A plus then B plus C. So it means that the grammar is ambiguous. So what are the reasons why that the grammar is ambiguous? First is multiple parse trees, and we successfully generated two structurally different parse trees for the same input string a plus b plus c. So it means that the grammar is ambiguous. And then the other reasons are different structural meanings. So um one tree interprets the interpretation as A plus B then plus C, meaning add A and B first, then add C. And the other interpret it as A plus B, A plus then B plus C, meaning we add we add B and C first, then add A to the result. And what are no precedence or associativity rule. So the production rule, A arrow to A plus A doesn't specify whether the plus operator should associate to the left or right, allowing multiple interpretations. And lastly, programming language problem. This ambiguity is problematic for programming languages because the compiler wouldn't know which interpretation to use, potentially leading to different results. So, therefore, this grammar is definitely ambiguous and would need to be rewritten with explicit associativity rules to be effective in programming language. So, that's it, and thank you for watching.